Cool, welcome back to our channel. So in this video, we are continuing to talk about the most important concept in system design, which is databases. Okay, cool. So in last video, we talked about the first type of database, which is relational databases, or it's more commonly called by SQL databases. Okay, so in this video, we will talk about the second type of database, which is non-SQL databases. So what are non-SQL databases? Oh, actually you can tell from the name. So basically, as long as a database is not a relational database, then you can call it non-SQL databases. So that means usually you do not store the data in tables. You do not store it with rows and columns, right? Which is typical in relational databases. So basically any non-relational databases, you can call it non-SQL databases or NoSQL databases, okay? So in non-SQL database, basically you can see it's a big scope, right? So it contains all kinds of other databases. But if you break it down, typically there are 5 different non-SQL databases which are usually used a lot. So the first type is called key value store, okay? So all key value database. So basically what it is, it's if you know about data structure in computer science, so it's basically like the hash map, okay? So in a database, you have a key which is used to query data, okay? And you also have value for the key, okay? So basically in the database, you store the data by their keys and values, right? And when you query the data, you just get the data, you just give the key you want to query, and then the database will return you the value it has from corresponding to the key, okay? So the commonly used or the commonly talked about key value store in production, okay? So there are, for example, DynamoDB from Amazon. Also there is Redis, which is commonly used as an in-memory key value store, and also it's also can be used for disk-based key value store, but yeah, but that depends on your use case, right? And also there is memcached.db, okay? Cool. So let's have an example of when should you use a key value store. So let's consider we are storing some, so your app or your web is allows user to play different games, okay? So let's say it's a stream, okay? So Steam, okay? So where you can play different kinds of games, right? So let's say we have a database which is game skills database, okay? So we want to, so for each game and for each user, I want to store what skills this user has acquired in that game. So basically, if you want to use key value store to store the user's skills in a specific game, the value should be the key should be composed by 2 fields, right? So the key should be, first is game ID, okay? And also the key should also include the user ID. So the key could be a composite key, right? So basically we could use 2 different fields to compose the key, right? So in our case, it's a game ID and the user ID. And the value, let's say it's a list, okay? So it's a list of skills, or it maybe betterly it's a JSON data. But here for simplicity, let's just use a list, okay? So which means for this user in this specific game, what skills he has acquired, okay? So for example, I could have acquired jump skill, I could have acquired with advanced guns skill, or I could have some acceleration run skill. Okay, so this is a value. Okay, so now let's say the user is currently begin to play this game in the next day or in some days. Okay, we during the loading of the game, we want to load all the skills that the user has acquired in this game, right? So then we just send a simple query, which is now, given this user ID and game ID, return me the value, right? So it's very simple. It's like hash map, right? So this is a key value store. Okay, cool. So this is the first type of non-SQL databases. And the second data type, and it's very easy to understand, right? And the second type is called document DB. Okay, so what is document DB? So document DB basically treat each data as a document. Okay, so basically, let's say you are a school, right? So you have information about all the students, right? So let's say you store all the students' information with papers, okay? So you store them on the shelf or something, or in some boxes, okay? So basically, for each student, you have a document, which is, let's say, for each student, it's about 5 to 6 different papers which are compiled together. Okay, so each for the 5 or 6 papers is one document about a specific student, right? So basically each student is represented as a document, right? So this is a real life example, right? So each student data is a document, right? So now let's give a more real example in product. Okay, so let's say we are storing we are storing the product information in DB. Okay, so let's call it product info DB. Okay, so there are multiple ways. You could also use some other kinds of databases, or even just use relational databases to store it. But let's say we want to use document database to store the product information. Okay, so here each product will be stored as a document in this document DB. Okay, and for each document, let's say you could have different fields for that for that documents, right? So for example, you could have the let's say the title of the product. Okay, cool. And you have the maybe unique identifier for the product. You could have description of the product. You could have let's say the price. Okay, so and also you have some maybe ratings for the products. Usually we don't store ratings in the document, but let's say we do have ratings here, which is some number between 0 to 5. Okay, and so these 5 fields are common for every product, right? But also for different products, there could be different other properties of fields, right? So for example, let's say for Switch games, I could also have the supported languages, which is field, right? And we could also have the age restriction field for the Switch game. Okay, and also we could have maybe supported platforms for the Switch game, right? So whether we can use Wii U or we can use just the Switch. Okay, so this is supported platforms, but so basically these 3 fields are only specific to the Switch game. Okay, so let's say this is a games document. Okay, cool. Game document. Okay, cool. And also in the same document database, we could also have another product, which is, let's say, dishwasher. document. Okay, dishwasher product. Okay, so here we could also have the common 5 fields, which are these 5 fields. It's common across all products, but also for this dishwasher document, we could also have some different fields, right, than other products. So for example, the size field, okay, and also the temperature it could goes to, okay, temperature, okay, cool. And also we could have the brand name, okay, and maybe some other, so maybe whether you have timer or not, okay. So this is the dishwasher document. So you can see different products could have some common fields, but most commonly they would have different fields, right? So you cannot store this, or you cannot easily store this in the relational database or SQL database, right? Because different products structure are different. They have different fields. So which means they should have different columns, right? So you cannot store them in the same database table, right? However, in document DB, you could store different products or store different documents which have very, very different fields into the same document database table, okay? So this is why it's called document DB, because we treat each database, we treat each data as a document, okay? Cool. So this is a document database. And also, so basically how do you query this, okay? So basically different products, different document databases have different query languages you should use. There is no common language which you could use to query document DB. And actually there is no common language to query non-SQL databases, right? So for different non-SQL database, there are different query languages. So the commonly used document database include MongoDB, okay? So this is the most commonly used document DB. And also there is CouchDB, and also there are some other DBs, okay? So basically, for example, let's say you are using MongoDB, and let's say you want to find all the products whose price is larger or greater than $300, okay? So for example, basically, depending on your language, okay, so basically this is a mock code, okay? So what you can do is you could query it like this. So db.collection.find. So basically I want to find products, right? So, and the filters are price, and I want to get price, which is greater than $300, okay? So with this, you can query all the documents we have whose price are greater than $300. So that's how you query document DB, okay? So this is the second type of non-SQL database, okay? Cool. Now let's talk about the third type, okay? We call it graph DB, okay? Graph DB is basically, it's like the data structure in computer science, which is graph, okay? So if you think about a graph, basically there are two concepts, right? One is node, right? So let's say here we have node, right? Okay. We have different nodes in the graph. So each node represents a real product entity in your system, okay? So for example, this node 1 could be a user, okay? So it's a user node. And for this node 2, it could be a post entity, okay? And for this node 3, it could be a comment. And then for this node 4, it could be, let's say, a product, okay? Cool. So, and also this is basically this is nodes in the graph, right? And also there's also edges between different between nodes, which represents the relationship between different nodes, right? So for example, a user could be connected to a post, and the direction is from the user to the post, okay? And their relationship is create, okay? The user create a post, okay? And also maybe there is another line, another edge from the user to the product, which is I buy this product, okay? And also maybe definitely there is another one, which is this comment, okay? From this comment to this post, okay? Or okay, so for this, maybe the relationship is comment on, okay? Cool, so, and also the user could also have an edge from the user to the comment, which is user create the comment, right? Okay, and also there could be comment to the product. So users could comment on different products to give their ratings, could give their evaluations about the product, okay? So this is the edge, right? So from here, you can see when should we use GraphDB, right? So the most, you should use GraphDB when you have a very complex relationships between your entities in your product, right? So, and you will query a lot about these relationships, okay? So for example, and usually the entities are created and they will stay very stable. And the most dynamic part, the most change part is the edges, right? In these cases, you should also use GraphDB, right? So, so this is a GraphDB, right? So we also give you the example, right? So user could create a post, user could create a comment, right? So this is GraphDB, okay? So what are the commonly used GraphDB? Okay, so one of the most commonly used GraphDB is called Neo4j, okay? So this is one of the GraphDBs, okay? So for example, let's say, similarly, let's say how do we query the GraphDB, right? So for example, I want to find users who commented on posts which are about chat GPT, and also the user clicked on OpenAI ads, okay? So we want to query this information, to query these users, okay? So how do we query these users, okay? So for example, you could, I will not explain details about the query, I will just write it out so you know what are the queries look like in GraphQL, in graph databases, okay? So basically you want to find users, okay? Maybe let's capitalize it, okay? So you want to find the users and they have edge to post and the relationship is comment on, okay? And the other end of this relationship is definitely post, okay? Cool. And let's say the topic is chat GPT, okay? Cool. And also we want to see whether they clicked on the OpenAI ads, okay? And also similarly, we want to, for the same user, which is represented as you, okay? And the relationship type is clicked, okay? And okay, cool. And also the other end of the relationship is ad, right? They clicked on the ads, right? And also the brand of the ads is OpenAI, okay? And now let's return the user ID, okay? Cool, so this is how you query graph database, okay? Okay, so this is a third type of the NoSQL database. Okay, so now let's talk about the fourth type of database, which is called column family database. Okay, so especially in column family database is mostly used in offline analytics data. Usually it's used a lot by big data analytics. Okay, so let's have an example to explain what is column based or column family database. Okay, so let's say we have this table. Okay, so I don't want to write it line by line, so I just want to save time here. Okay, so cool. So now let's say for video ads, so we have video ads in our system. Let's say we are Facebook or we are Amazon, we have video ads, right? So we want to log the user event on each ad. So the user event could contains, okay, so we have a user ID. Okay, so for this user, they watched this video, okay, which is represented as video ID. And we want to log the watch time spent. So how long, how many seconds the user watched this specific video, okay? Whether they clicked this video, what's the video topic, what is the video topic about this video ads, okay? And also when the user watches the video, did they unmuted the video? And also did they watch this video in full screen? And whether they turn on the subtitle of the video ads, okay? So let's say we have 500 more fields logged for each record, okay? So let's say we have 500 more other fields logged for each record, right? So basically in a row-based database or in a relational database, we've talked about this before, right? In relational databases, so for each record you have the column, right? So in this example, you would have 500 columns for each record, right? And each record is stored as a row, right? So for example, in this example, for user ID 10002, when he watched this video 30500099, and we log this event in this row. And then in the next row, we logged a different user's data on a different video ad. And in other rows, we logged other users' data on different video ads, right? So this is how we do it in a row-based database or in a relational database, okay? Cool. So what it will look like, what the storage will look like in a column family database, okay, in a column database. In a column database, actually we store the data for each column, okay? So let's say I will store all the data for user ID column together in the database, okay? So for user ID, I will just store this number, okay. I will also store 100,111. I will also store 110,199, okay. So basically all the data for the user ID are stored, so all the user IDs are stored together. You can think we store it in the same file. We store them continuously in the same file, okay? So we store them as user ID, okay? And also we store video ID, okay? And this is 3050099, and okay, so it's 79, and also we have 159, okay, and other data, okay. So this columns data will stay together in the same file or in the same place, okay. So it's not stored, so okay. And also for watch time spent, okay, and all the watch time spent column data will be stored continuously together, okay. So they will be stored as this, okay. Cool. So here you can see we break down each record into different data, right? So for example, we didn't store each record continuously in the same file or in the same row, right? Instead, we break down the record by columns. So each column's data is stored continuously together, okay? So this is why we call them column family database, okay? Cool. So you may ask, why do we store them in such a strange way, okay? Why do we want to store them as columns rather than rows? Because it's more easier to understand and manage if you store them in rows, right? Because each row is an entity, each row is a record. It's easier to understand, right? So why you store them in such a weird way, okay? So that's because usually in big data, so again, I want to emphasize, usually column family database is most commonly used in offline data analytics, in big data analytics, okay? So it's used by big data queries, okay? So in big data queries, usually you don't care about each row. You don't care about this specific user's data, right? You don't care, okay, this user watched this video for about 3 seconds. That's not what you care. Usually you care is about the aggregated data, right? So let's take an example. Let's say what we cared about is the average watch time spent across all the video watches, okay? So I want to get the average watch time seconds, okay? So if we store them in row-based database, basically you have to read all the rows to get the watch time for each row, and then you sum them together and then divide them by the number of rows, right? So basically, in order to get the average watch time, so basically you only care about one column, right, in our query. However, you have to read all the other columns because you have to scan all the rows to get the watch time spent for each record, right? So that's how you get watch time spent. So in our case, you can see we have 500 more fields. So just because we want to calculate one single column, which is watch time spent, you have to read all the other columns behind the scene, right? That's a waste of resources, right? There's no need to do this, right? But you must do this in row-based columns because the column data, the watch time spent, this single column is stored in a entity, right? You must read out the whole entity, and then you can get the data. Okay, cool. So this is row-based database problem. Okay, so but with column family database, it's very different. As we said, all the data for a single column are stored together. Okay, so for example, for watch time spent, they are all stored together in a single place continuously, okay? So basically, when you calculate the average watch time spent, you just read this single data, okay? You just read the watch time spent place, and you can get all the watch times, right? And then you can just sum them together, right? So in this case, because you only read the watch time spent column, you didn't read other user ID, video IDs, unmuted video in full screen data, you never read other columns, right? So you only read this single columns data, which is actually what you cared about, right? So the efficiency will be much, much high, right? And which is pretty critical for big data analytics, right? Okay, cool. Now, I want to emphasize again, the reason why we store them as column is because the use case, the most commonly used case for column family database is in big data analytics. And in big data analytics, we don't care about a single data. We don't care about what a specific user did, what a specific video performs. We care about the aggregated data. We want to analyze the aggregated data such as sum, average, the top K, or some other queries, right? So we only care about the aggregated data. So that's why we store them as columns, because it's more efficient, right? And if you think more about it, each column is actually is a single type, right? So for example, for watch time spent, it's always integers, right? So because we store the same type of data together continuously, we can run some very, very efficient data compression algorithm because they are the same type, right? So we can compress the data also efficiently. So we can use less storage, right? So this is an advantage too for the column-based database. Okay, cool. And this is a fourth commonly used database. And also there are some other databases such as time series database. Okay, so this database basically you can store some time series data because usually you want to query data and visualize with dashboards and visualize with some interactive apps, which is showing the time series data, okay? And also you want to see the relationship between different time series, or you want to see the data trend between different time frames, right? So that's a very special use case, right? So that's why they also have time series database to store time series data, okay? Cool. And also the commonly used time series database include Influx, DB, Timescale, DB, and some others, which personally I didn't use them because I didn't have my own use case for my own apps. Okay, cool. But if you want to learn more, you can read their documents or just find some tutorials around them. Okay, and also for column database, column family database. Okay, so there are some very common products you heard about a lot, which is Cassandra and also HBase and also some other databases. Okay, cool. So let's summarize this video. In this video, we talked about the second type of database, which is NoSQL database. Okay, so basically we talked about the key value store database. We talked about the document DB. We talked about graph DB. We talked about column family database, and we also talked about the time series database. Maybe I have missed some other types of database, but I think for system design interview and for your own use cases, mostly you will just use key value store or document DB, right? And for your offline analytics, especially working in big companies where they do have a lot of data, so yeah, then definitely you will get in touch with column family database. Okay, cool. So thank you for watching this video, and don't forget to subscribe to this channel so you can get the latest video in real time. And thank you for your support. I would really appreciate it. Thank you. Bye bye.